Good day and welcome to the part B of the test, the September 2024 test for Mathematics Grade 8. We're going to deal with some geometry today, and this will be straight line geometry. So first of all, the general idea is you must give reasons for every conclusion or every statement you make. You must give a reason why this is such also. And if you're going to mention or use ZFC as a reason, your alternate angles corresponding or your co-interior angles, you must mention what lines of parallel that you are using to make use of your ZFC. All right, so first things first, 3.1.1, angles around a point add up to, and you should just know this, yeah, it's 360 degrees. The size of one angle in an equilateral triangle is, well, 60 degrees. Every angle in an equilateral triangle is 60 degrees. The complement of 90 degrees is, so we have complement and supplement, so complementary angles add up to 90 and supplementary angles add up to 180. So 60 plus what gives me a 90? It is 30, because they are complement. They must add to 90. Right, here's the first question, 3.2.1 of the geometry. We have two lines, and then we have A, which I was a bit skew. There's an A there, a B, and a 72. So on the right there's some tips. The first tip is that if we have two lines that cut each other like this, that bisect, we have these opposite angles are going to be the same, and same for the two blue angles will also be the same. So the red angles are the same, the blue angles are the same. We call it vertically opposite angles as a reason. Next, if we have a straight line and two angles on that straight line, the blue angle and the red angle will add up to 180. And the reason being angles on a straight line, as we see over here. All right, so have a go at that, and then I'll mark it in 5 seconds, 2 seconds, one to go. I can mark it now. So let's start. If B is across 72 like this, we're going to say that B is equal to 72 degrees, and that will be because of vertically opposite angles. So if you take a look here, we have these two blue angles across from each other with two lines that cut each other, and that B will be a 72, and that we call vertically opposite angles. A then, oh wait, before we carry on in geometry, you want to, if you find anything out, you want to write it like on your question paper, what you just found out, and so that you can actually work something out. So A, you can find with angles on a straight line, can't you? So we say then, as we've shown here, that A plus 72 is 180. A plus 72 equals 180, and that is angles on a straight line. Right, and I just included that vertically opposite angles there. So quite a straightforward one. This, we have a mark and a mark like that. All right, so then we go to 3.2.2. We have this diagram over here, PQ, PTQ, and KJ. I assume in the question, I can't remember, but I think these two are parallel. They have to be for us to solve this. So we take a look on the right. Here's some tips. We have to use ZFC. So looking at Z, those two, that's alternating angles. Those two angles that are shown in blue will be equal, as I've shown up here. They'll be equal. By F, if the shape looks like that and its parallel lines are in that way, we say those two angles are also equal in that shape. And if we go to the right, those two interior angles, if it's got a C shape, those two interior angles will add up to 180. All right. So, and the second rule we're going to use here is obviously your straight line. Those two angles just add up to 180 because they are supplementary on a straight line. So we have PTQ and we have KMJ. So good idea is to start with looking, your eye must catch something you know, and then working from there. So there's a 130 there as well. But I'm going to start with the 54. Can I find anything else? Sorry, can I find anything out with that 54? Yes, I can. Is that not a Z shape? Backward Z with two parallel lines. Yes, so that C is that 54. So we can write, C is 54, alternate angles, PQ is parallel to KJ. But you could have mentioned some other ones. You could have said TQ is parallel to VJ or VM. It doesn't matter as long as you got those two lines shown. Right, so we find something out, so we write down 54 over here. And then we can look at something else. We can see that this is a C shape. So this angle and this angle will add up to 180. So we can say E plus that 130 is equal to 180. So let's write it down. And there we go. E plus 130 equals 80, 180. Co-interior angles and PQ is parallel to KJ. And so we know that once we write it down. Oh, we haven't solved it yet. Oops. So that E, we have to split our terms like we did earlier. We take it 130 across. It'll be equal to 180 minus that 130 term, because it changes signs as it goes across. And we get E is equal to a 50. E is a 50. So we put it in. All right, so knowing that, I can see something really cool here. I can see a straight line. I can see 50 plus a D plus a 54 is equal to 180. So I can actually find the value of the D because I only have one unknown in that equation. So let's write it down quick. There we go. 50 plus D plus 54 equals 180, angles on a straight line. So I just solve for D as I do with my algebra. And I'm just going to chuck all these constant terms across, leave D by itself on the left, and then it's sorted. So there we go. And then I simplify. D equals then a 76. There we go. So let's go over to question 4. We can do some straight line geometry with algebra. So if we go back to algebra in question 2, it's the exact same process. There's nothing new about it. It's just we kind of have to apply algebraic principles within our geometry that we've done here in question 3. But there's some algebra involved. Not that there isn't algebra involved here, but more like you'll see now. So it says here, calculate with reasons the size of x. We have this diagram over here. There's some parallel lines there, so I can maybe do some ZFC over there. Let's take a look. So the tip here is we're going to use ZFC again. And yeah, so I don't know what I've ticked off there, but let's see if you can use alternate angles corresponding or co-interior angles to solve the value of x over here. So what we do is we look at this shape over here, and we can see, whoa, that's actually corresponding angles. It's backward F. There's our two parallel lines. And so we can actually say 6x plus 10 is equal to 4x plus 40. And solve that equation. Pretty cool. So let me write that down quick. And there we go. So 4x plus 40, there it is. It's equal to 6x plus 10, 6x plus 10. And then I just solve for x. Split my terms, always. And then I put, I'm going to take my 6x over that way, and I'll 40 over that way. Alright, so I'll put it like this, and then 4x minus 6x will just be a negative 2x, and they'll be equal to, equal to a negative 3. And then I say all terms divide by coefficient of x, which is negative 2, and then I get, well, we can maybe, okay, let's rewrite it. 2x over negative 2 is equal to negative 3 over negative 2. And we get an answer of x equals 15. Alright. Alright, looking at this shape over here, we have, it seems like no parallel lines, but we have this triangle being an isosceles triangle. Now just my inspection, knowing that these two, this is an isosceles triangle, I know this angle does, that's the same, right? So it's actually 55 this. And then, yeah, let's see what we can do over here. There's some tips. So we have an isosceles triangle, like I just mentioned. If you know the two sides, you know that the two angles are alike. And if you know the two angles are alike, you know the two sides are equal as well. And then we cannot use external angles of a triangle here because it has to look like this. It has to be a continuation of one of the sides. This is not a continuation of one of the sides. As you see, that doesn't continue with one of the sides of the triangle. It's required. All right, so number 3 is we can also use internal angles of a triangle is equal to 180 to find the value of this x. Right, so we forgot to mention that these two lines are parallel. Right, so if I know that's 55, this is an isosceles triangle, this HGK. Let me just make it neater. HGK. So then I know that this angle is the same as this angle, as we've shown here. So that's also then a 55 on the right. And then we can, with internal angles of a triangle, find that angle over there, that H. And because we know H, we can actually then, because we know H, we can actually then do the Z. That is your alternate angle. So that H value is then equal to x plus 45. So that is the process we are going to follow. So try that yourself, and then we see if you can get it correct. Alright, so right on here, angle GKH is equal to 55 because it's an isosceles triangle. But when you give a reason, you have to kind of say the strange thing. It says angles across equal sides. So you have equal sides, the angles across the equal sides. Just you have to memorize that one. You can't say angles of an isosceles triangle. So you have to use this phrase over here. It's very important. Alright, so now that we know that's 55, we can then work out what that H is by using internal angles of a triangle. And there we go. I've written down 55 plus that H over here, that missing H, is going to be equal to 180. And that's because of the internal angles of a triangle. So therefore H is equal to 70 degrees. If we just take it at 55, it'll be 110, right? So let me just do the right working out here. So it's 110 plus H equals 180. Take the 110 across, and then we get that minus, so it'll be a 70. Angle H is a 70. So then we write it down. 70, and then we say then what we said earlier, that this is alternate angle. 70 equals x plus 45. So I'm gonna write that down. There we go. 70 equals x plus 45. Those two are equal, and that is because of alternate angles, the z shape, and we have to say what's parallel. GH is parallel to KJ, and then we just solve this algebraically. Take the 45 across, will be x equals 70 minus 45, and then we end with an x equal to 25 degrees. Easy peasy. All right, let's go to 4.2, which is the last one. So they're not telling us what's parallel, but they want us to prove that it's parallel. So what we know is that this C2 angle over here, 30, is the exact same as this D2 angle over here. So what you do is you show the shape, that it's an F shape, that these two angles are the same in the F shape. And because of that, we know that these two lines are parallel. And that's how you prove it. So instead of them telling us it is parallel like this and leaving that one out and telling us what is x, we know x is 30 because it's corresponding angles, and AE is parallel to BF, right? But they're giving us that value and asking us, show that line AE is parallel to BF. So you have to have some backward reasoning for F. So you say then angle C2 is equal to angle D2. That is just given value, they gave it like that. And you say therefore angle AE is, angle side AE or line AE is parallel to line BF. And like I said earlier, you can also say DF, doesn't matter, like DF, DF, BF, and the reason being that it's corresponding angles. Okay, there we go. So I hope that helped you. Let me know, like, subscribe, for more videos, and please leave a like. I said that already, and feel free to comment or ask me some questions in class. Take care.